This is Euclid Book 1, proposition number 33, and we're trying to prove two things. Number one, we're trying to prove that AC is equal in size. If you were to measure this with a ruler, it would be equal in size to line BD. And we're also trying to prove that line AC is parallel to BD. Now, how are we going to do this? Well, Euclid first says that we have a line here, and it is AB. And he says, then we have another line down here, it says it's CD. Now, AB and CD are parallel to each other. They are also equal in size. If you were to measure line AB and line CD, you'd find out their measurements were equal. Alright, having said all of that, we can now say, first of all, that angle ABC is equal in size to angle BC, or actually BCD. This is BCD. So this angle here is equal in size to this angle here, and that is because of proposition 129. Okay? Now, so far so good. We already established that AB and CD are equal. We can also say that line BC is equal to itself. So now, because we're using the side angle side theorem of Euclid's, we can say that this triangle here and this triangle here are exactly the same size. Alright. Because this triangle here and this triangle here are exactly the same size, we can then say that AC and BD are equal in size. If you were to measure this with a ruler and measure this with a ruler, you'd find out that these two lines are exactly the same size. But there was one last thing we had to prove, and that was that line AC was parallel to BD. Now, how do we do that? Well, we've already established that this triangle here and this triangle here are exactly the same size. Therefore, this angle here, DBC, is exactly the same size as ACB. And because these angles alternate like this, therefore, by proposition 129, AC is parallel to BD. And that's everything we were trying to prove. Okay? Hopefully you got all this. If you didn't, leave me a comment down below. I will try to help you out as best as I can. I will tell you more in the future videos, so stay tuned.